Okay, in this video, we're going to introduce classical probability and Venn diagrams. And classical probability for most people is the most challenging part of all statistics. So please pay very careful attention to this. So mutually exclusive and disjoint. First off, those are synonyms for each other. Mutually exclusive and disjoint mean exactly the same thing. And they're events that cannot occur at the same time. For example, if you have a 50% chance, if you have a fair coin, you have a 50% chance of getting a heads and 50% chance of getting a tails, but you can't get both at the same time. And since you can't have both occur at the same time, it's not, or it is disjoint. It is mutually exclusive. If it were not, if it were not mutually exclusive, there'd be an overlap. But in this case, you either get heads or you get tails. You can't get both. And because you can't get both, this would be a mutually exclusive event or a disjoint event. Also, you can't make 100% on the test and make an F on the same test at the same time. All right, you either got an A, a perfect score, or you made an F. You couldn't have gotten both. All right, but we also have more opportunities. So let's just pretend that we had a 20% chance of making an A, a 10% chance of making an F. So the other possibilities make up the remainder of the population, and 70%, which are not an A or an F. So in this case, that would be a B, C, or D. So there's a 70% chance you made a B, C, or D, 20% chance you made an A, 10% chance you made an F. This is a way of Venn diagram that would show that. And notice once again, we have no overlap because you cannot have both things occurring at the same time. In a prior video, we talked about complementary events. And complementary event is 1 minus the probability is the complement, okay? So for example, the complement of heads would be tails, or in other words, not heads. So not heads, or equivalently, we could have said tails. The complement of A would be not A, which in this case would be B, C, D, or F. All right, the complement would be what it's not. The complement of tails would be heads, or just saying not tails. The complement of F is not F, which would be anything but F, which is A, B, C, or D. Independent events. In a prior video, we talked about events being independent, and if they were, we could multiply them. And we said that one event does not impact another. We also said that they're proportional. And what it means is the probability of A and B equals the probability of A times B. In other words, and this is the intersection symbol. So in other words, to think of intersection, we can also think of, and this is and. It's also intersection. And that's the overlap in a Venn diagram. All right. So if independent A and B equals A times B, this is only true if they are independent. Please note, mutually exclusive is not the same thing as independent. Matter of fact, there are big differences. Also, events cannot be mutually exclusive and independent. I just usually want to stop right there. Events cannot be mutually exclusive and independent. I'm really going to say it one more time. Events cannot be both mutually exclusive and independent unless one event's probability is 0. However, we really don't care about the probability of 0. Why? If something has a probability of 0 and I ask you how often is it going to happen, you're going to say it's never going to happen because it's probability of 0. So consequently, not very interesting. So in general, events cannot be both mutually exclusive and independent. But every now and then, some math guy will say, unless the probability is 0. And that's true, but that's not very interesting. So let's take a game that requires you to roll a fair 4-sided die, numbered 1 through 4, and to flip a coin. The Venn diagram off the sides illustrates the probability of getting heads. So the probability of getting heads would be this circle right here. You're like, no, that says 0.125. I go, oh no, we got to include that overlap. If we add those together, we end up getting a probability of 0.5. So the probability of this circle, which is heads, is 0.5, and that's what we would expect. And it also says the probability of getting a 1, 2, or 3 on a 4-sided die. Well, on a 4-sided die, I can get 1, 2, 3, or 4. So the probability of a 1, 2, or 3 is 0.75. And if I add 0.375 up and 0.375 up, I do get 0.75. But you're probably wondering how in the world I knew to divide this up, and you'll have to give me just a moment to get there. So this circle, I have 0.75, and in this circle, I have 0.5. Now, to think about this, I want you to consider this. If I flip a coin and I roll a dice, those are independent events. So one does not impact the other. And if events are independent, we said that we can multiply them. So in this case, we could sit there and go, you know what? The probability of a 1, 2, or 3 was 3/4. The probability, and we were interested in getting a heads. The probability of a heads was 1/2. We know we can multiply those, and if we do, we end up getting 3/8, which is the same as saying 0.375. Oh, probability of A and B equals the probability of A times the probability of B. That's what we just said. We basically said the probability of the 1, 2, 3 and the probability of a heads. Now notice, that's the overlap symbol. And we just said that our overlap was going to be 0.375. So I have to have 0.375 in this part. So if I have 0.375 in this part, the probability of a heads equals 0.5 minus the 0.375 gives me 0.125, which is where this value came from. The probability of a 1, 2, or 3 was 3/4. So the probability of a 1, 2, or 3 equals 0.75 minus that overlap equals 0.375, which is this part. Now let's take a moment and let's all add all this up together. Well, if I do that, I get 0.125 plus 0.375 plus the 0.375. And when I do that, I end up getting 0.875, and that doesn't add up to 1. So 1 minus the 0.875 is 0.125, which is the probability of not getting any of those things. All right? That's the probability of not getting a 1, 2, or 3, and the probability of not getting a heads. So essentially, what is this? This is essentially the probability of a tails and a 4. A probability of a tails and a 4. You're like, those are independent, should be independent, so I should be able to multiply to test that out. Let's try that out. What's the probability of a tails? 1/2. What's the probability of a 4? 1 out of 4. That's 1/8, which happens to be 0.125. Okay, so that's showing the work on a Venn diagram, and in the next video, we're going to spend some time with a Venn diagram and break it down a bit more. But I need to introduce one other thing, and that is the general addition rule. Now, they will give you this formula on the formula chart, so you don't have to memorize it, but I think you should just because we use it so much. And it's the probability of A union B equals the probability of A plus B minus the intersection. And what that means is usually they'll say either or both. What's the probability of either or both? And if they say either or both, they're talking about union. Now, we've said that or means add. And in past, when you were in middle school, you just added probabilities. And the reason you added probabilities was they were mutually exclusive. There was no overlap. The probability of getting a heads or a tail was heads plus tail is 100%. The probability of getting an A or an F was 0.1 plus 0.2 is 0.3. You could just add them up and you're good to go. But here we're going to start having overlaps. And so with the general addition rule, we have to subtract, all right? And the reason we have to subtract is if we add it up, what's the probability of getting a heads union the probability of getting a 1, 2, or 3? Well, if I added a heads, I have 0.5. This is plus 0.75, and that's greater than 1. So something is wrong. And there is something wrong. Because look, they share that 0.375. So essentially the 0.375 got counted with the heads, and it got counted with the 1, 2, and 3. So I have to only count it once. Since it got counted twice, I'm going to have to subtract it out. So we want the probability of A union B equals the probability of A plus the probability of B minus the probability of A and B. Well, the probability of a heads was 0.5. The probability of a 1, 2, or 3 is 0.75. Then I subtract out the intersection, which was 0.375. And I find out the probability of them both occurring is 0.875, which is interesting because what's not counted for was the 0.125, which is the probability of getting a tail or a 4, a tail and a 4. This would be a tail and 4, all right, is a 0.125. The probability of either getting a heads or a tail, a heads or a 1, 2, or 3, or both is this 0.875. Okay? All right, the next video, this will start to make a little more make a little more sense. So please pay careful attention as we go to dog cat.